we'll look at another higher order function called fold. Again, right, let's explain fold. Fold takes the function that takes two arguments, and then it takes another list and also an initial value. Now, fold will apply this function, right? You gave me a function. I'll apply this function to each member of the list. Every time also send this accumulator, we call it, right, initial value, and eventually I'll combine them together, right? So accumulator, if you for addition, it's a 0, or multiplication, it's 1, and then it will accumulate. So that is fold. Let's really look at some examples to understand it. So this is my fold function. That is, I send a function that takes two arguments, two integers, and calculate the sum of those two integers. I'll send a 0 as an initial value or accumulator. Now what fold does, it takes one item from the list, applies this function to that item and my initial value or accumulator. In this case, look at that. So I will apply this to 0 and a 1. With these two, it'll calculate 1. Next time, this is my new accumulator. So next time, I'll take another item from the list. I will use that new accumulator. That's 1 and 2. This will calculate 3. Next time, I take another item and apply that f right here. This whole thing is f to this new two values, and it'll become 6. So 6 will become a new accumulator. I'll take 4, apply f to 6, 4. That's what fold does. It takes one item at a time from the list and accumulate it to the accumulator. With that, we get 15. That is, just add all the numbers in this list, right? In this list. So, just like the map, let's look at this example, why we need this fold. So, here's an example. It's a sum of the list, right? This says, if you give me a list, right, add all the values. So, if the list is empty, it's 0. Otherwise, I will take the head. And if you give me the sum of the tail, I'll just plus the head. That is my sum. 1, 2, 3, 4. That sum is 10. Another one, that will be a concatenation. So if you give me a list of strings, I'll all put them together, make it the one string. That is, if it's an empty list, I return an empty string. This is a concatenation in OCaml. That is, if you give me a head and tail, if it's not empty, I will concatenate head to whatever. After you make the tail one string, I'll just concatenate with the head. With that, if you give me ABC, it'll become one string of ABC. Now, just like the map, now let's look at the same parts and different parts. Definitely, the name of the functions are different, right? And then this part is same, right? Is same, and then this is different. That means if it's empty, right, I will return something, and that can be different, right? That can be different. Other than that, what is different? This operator based on a function, I do different operation. That's it, right? That's it. So now if you generalize, okay, if you give me a function, my function does this thing, right? This is a different thing you do. You gave me an f to do it. Good, I can do that. And also, I could return different things. You give me an accumulator to do that. That will give me a fold function. Now look at that. The fold takes an f. This f could be a sum. This f could be the concatenation, right? And this accumulator is the last thing that you're going to return. That's what we did. If it's an empty list, return that accumulator. This could be 0. This could be an empty list, empty string. This could be true. This could be false. This could be a floating point number. Otherwise, right, if it's not empty, look at this part. See, we apply this f, right, apply this f to the head and the tail. That is, I'm going to apply this f to the accumulator and the head, right, and make this a new accumulator then that means I'm going to do the same thing to the tail, right? This one important part, that is, you apply this function to this accumulator and then a head, right? Head, and use it as a new, right? New accumulator. So let's see examples how this thing works. Oh, yeah, sorry. Let's look at the types, right? Before we look at examples. This is an implementation, right? Let's look at it again. Fold takes a function, an accumulator, and the list. If the list is empty, it returns an accumulator. Otherwise, apply that function to the accumulator and the head. This will become new accumulator in the next iteration of the fold until this T becomes empty list. Right? That is my fold, really. So now let's look at this type, right? I know you're paying attention. Let's see that. So this function f, a fold takes a function. This function, let's say it takes this function. Now it takes an accumulator. I don't know what the accumulator, let's say accumulator is any type of T, any type of tick A, right? Tick A. And then, so this return type is tick A. So, right, this return type is tick A because of this. If this is tick A, that's my return type. So this is ACC. And then what is a type of list, right? List. List can be anything here. Because I'm applying, so let's F, if F it takes a tick A, from this, right, I know it takes a tick A. Head, I don't know what that thing is. Let's say that's a tick B. If this is tick B, definitely this thing is here. It's tick B list, because if you take head is tick B, then this list is tick B list. So we got these. Now what you're going to generate, right, if you take an A function, the F function takes an A, takes a B, this is a whole result here. You're using it again as an accumulator for the next iteration. That means this whole thing should generate a same type of tick A. I know, this can be confusing, right? Because this red part, this result, I'm using as an accumulator for the next recursion call, right? Next iteration, so that's tick A. That means this whole return type, this is tick A. So if we put together, that is, it takes a function that takes two arguments, A and B, and returns A, tick A. It takes an accumulator tick A. It takes a B list. And then it just takes one item from the list, combine with A, fold it, fold it, fold it. At the very end, return one single type of tick A, okay? Tick A. So if you put all together, that is this. It takes an A, B to A. My accumulator is tick A type. List is a tick B list. Eventually, I'll combine them all together, return the same type of the accumulator. That is tick A. I know all of you understood this 100%, so I should continue. How we use fold? Now let's look at some examples. That is, I have the function ADD, takes two integers and adds them together. So if you give me a list 2, 3, 4, I will apply ADD to the 0 is an accumulator and then a list. So based on what we just said, right, fold, ADD will take 0 and the one item from the list, that's 2, right? So then I do ADD on this, and this thing next time it'll become my accumulator, and then I take 3, I'll apply ADD on this. Next time this whole thing will become accumulator, I'll apply ADD to this whole thing. That becomes 9. After that, my tail, right, list becomes empty. If it's empty, we return this, whatever's accumulator, that will be 9. So when the list becomes empty, I return the ACC. That's accumulator. That will be the 9. So, right, this is an execution. the process, right? ADD 0 list, it takes 2. This thing will become new accumulator. Next time, this, right, if it's not empty, right, it comes here, takes head and tail. So head is 3, tail is 4. Apply ACC, and the head, that's 2 and the 3, that becomes 5, right, red thing right here. And then it'll go in as a new accumulator. So it's times 4, that it becomes 8, 5 plus 4, this is 9, right? And then this list became empty. If the list becomes empty, when you enter, call fold, if the list is empty, right here, we return ACC. It's accumulator. So accumulator is 9. You got that, right? That's the entire result, right? With that, let's look at some examples. This is a calculation, it's a product of a list. Exact same thing like what we did is addition. Give me 2 integers, I will multiply them. So if you give me a list, I will multiply them, right? Apply the small to each item of the list as with an accumulator 1. That's a 1 multiply 2 multiply 3 multiply 4 multiply 5, 120. Easy mistake you make. If you send the wrong accumulator 0, the whole result will become 0 because it takes 0 multiply 1, and the result is 0. Then new accumulator is 0. So if you keep multiplying everything, eventually you get 0. So you have to be careful here, right? Let's do another example. This example is definitely a little bit more. That is, I will take a predicate function P and the list. I will apply this predicate to each item of the list. If it returns true, I'll take it. If it returns false, I'll count it. If it returns false, I don't count it. That is, I'm going to apply P to element, right? Each element. That's how you get the element. The fold does that. Fold will go to the list, take one element, send it to this anonymous function that comes as an element, right? Well, how about the counter? That's a 0. Like these 2 arguments come into the function. This is 0. This is one item from the list. If that item, I apply predicate to that item. If it's true, then I increment. Otherwise, I keep the same value. I do not increment. With that, you can count based on the predicate. That is, given the list 30 to 0, this list, give me the number of items that is greater than 0, right? So I apply this function to, right, this list. Then 30 is greater than 0, 45, 100. I have 3 of them. But implementation really use just fold. Imagine if you don't use fold, right? Then you have to have a loop or recursion to do that. But here, fold is doing the magic, right? I'm applying this thing, accumulator 0, to the list. So this entire function, for the function f for the fold is this long anonymous function. You can also name it and send a name. That is fine. That's my example 2. Let's do one more. I know you like it so much. We have a lot of examples. It says collect. Right? If you give me a list of integers, collect all the even numbers. That is, right? I create a function, right? ACC and y. If the value y is an even number, then add it in front of ACC. ACC is a list in this case. Because of this, it's a list. Otherwise, keep that original accumulator list. Cool. How do you use that? I'm going to send this f to fold. My accumulator is an empty list. And then what the f does? F apply to empty list and 1. 1 is that not an even number. I'll skip. So I still have the same accumulator. When it comes to 2, 2 is an even number. I will add 2 in front of this list. I have 1 item in the list. Next time 4, next time 6. I have 6 for 2. Only caveat here, it's reversed because you take, when you see 6, you add it in front. If the 6 is even number, add it in front. That's how you get this reversed list. So in the future, if you want to keep them in order, after you get the list, you can reverse it. So there is this linear time reverse function, right? List.reverse. or you can write your reverse function, okay? So this is collecting all the even numbers. This is the entire thing. Just one fold will do that for you, right? Fold is definitely, again, very, very powerful. Now, your head will spin. This says, I give you two lists, length is same. You multiply each corresponding items, and then you add the results back. So for that, I'm going to use a map2 function. It's given inside a list module. It's a different version, variation of the map. Instead of taking one list, it takes two lists, and then applies that f to one item from list A, one item from list B, and then create a new list. So in this case, if I send an addition, it'll take one item from A, one item from B, right? Applies that f to the head of list 1, list 2, create a new value, and then add it to whatever is the result of processing the tail. That will do x1 times y1, x2 times y2, x3 times y3. Now, how do you add all of them together? That's fold, right? Fold takes a list and then add all of them together. This whole function will be this. Product of v1 and v2. v1 is here, v2 is here. That is, I'm going to fold it. This is that addition function, plus inside a paren is just the addition function that takes two integer returns and one integer, right? It's like an operator overloading. My accumulator is 0. What is my list? This is my list. That is, I'm going to apply map to the list of v1 and v2. And this is a multiplication function. Here, there's no space. Here, there's a space because if there's no space, it'll become like a comment. So you put a space. That means this is a multiplication operator. If you give me two things, I'll multiply them together. If you give me an int list and the int list, I return one single int. That would be, if you give me 264, 135, that's 2 times 1 plus 4 times 3 plus 6 times 5. That is 44. Look at this. Just this one short line of code will do this entire thing for you, right? If you compare with verbose Java, you'll appreciate how powerful the fold is. You have an appetite for one more? I don't think so. I still show you. I'll give you a list. Find the maximum item from the list. This is if you give me a list, give me maximum item. If the list is empty, there's no maximum. I can't return an empty list. You're asking for a max. I will fail. I throw an exception. I say, hey, you gave me an empty list. You're asking for a maximum. If you give me a head and tail, it's not empty. I'll take the head. That's my current maximum. And then I will compare that current head. I assume that's the current maximum. And every single item from the tail, that using this max, comparing two functions. That is, look at that. If you give me 3, 10, 5, I'll take 3 as a head, and then compare 3 to 10, take the maximum as an accumulator, compare it with 5, not still, 10 still stays as accumulator. If you see 20, yeah, 20 will become your accumulator. At the end, see the process, you get the maximum value. This is very cool function, maximum value from the list. That concludes my examples. I'll give you 2 more to practice after the quiz. Tomorrow's quiz, don't do that. We don't have that for the quiz, but after the quiz, you should practice. That is, I'll give you a list of lists. Calculate the sum of each list. That's the first list is 6, second list is 4, third list is 18. How are you going to do that, right? You take a fold, you take a map. This is my function. Map fold 0. This will do the exact same thing. Look at that. If I apply this to this function, it'll give you this list. Look at this. This is the entire function. It's beautiful and powerful, and it calculates correctly, okay? And one more, if you're, interviewing for Google or something, this is definitely I know it's a difficult interview question. That's if I give you a list, give me a sublist, add them together, it's a maximum value. So in this list, in this case, if you 4 minus 1, 2, 1, if you add them together, it's a 6. If you add another one more item, then you don't get 6. Definitely smaller than 6. That's a maximum value with any sublist in this list, right? That's the difficult question, even with any like Java or C, where you have to think about it. And this is a solution I gave you. Again, it is a beautiful solution. So let's summarize everything we learned today, right? Map takes a function, applies that to each member of the list, creates a new list. Fold will take a function, take an accumulator, and it takes a list and applies this function to the accumulator, and each member of the list eventually combines them together will give you one accumulator. Isn't it cool? I did a little bit fast maybe, but definitely you can watch a video. I'll see you next week. Tomorrow is a quiz. I'll miss you.